Alright guys, so this will be your video for multiple angle and product to sum formulas. So as we go through this, keep in mind that we are going to be using other trig identities, so having your formula sheet either like on your phone or next to you is going to be really helpful when working on these problems. So here we are on page 1. This is the guided notes that's also available on your Google Classroom to print out or to copy. If you can't print it, I definitely suggest copying it. I also suggest note cards. It's going to make it easier to kind of go through your identities and figure out which ones are going to be relevant. Or just like I said, having that formula sheet. So let's start with what we call our double angle formulas. So you can see that if we're looking at our double angle formulas, our initial trig function has a double angle, right? 2 times theta, or 2 times u, or 2 times x. So you're going to see that if it's double here, or if you have like a value on the inside of your trig function, we can break it up. So these are your there's 3 trig functions, but there's actually 5 different options here for your double angle formulas. So sine's pretty straightforward. Cosine, you have a couple options. These are technically all equivalent. Okay, so you just need to be able to determine which one you want to use. So for instance, we're going to be doing an example in a minute where we want our answer totally in just cosine. So that's telling me that I'm definitely not going to be using this first one up here because it has a sine in it. I actually just noticed an error here. This should be sine. I wrote that in incorrectly, so let's change that. That should be sine. Oops. Okay, and that one, like I said, that one has a sine in it, so if our answer wants to be cosine, not going to work for us. So you're going to have to be able to choose between the 3 options for cosine. And then tangent is again straightforward, just pretty much whatever you see here. Now we can also use this double angle formula when maybe you see a 4 theta or a 10 theta on the inside of your trig function. So next we have where you can see how to apply this when you do see different values. So for instance, when you do see a 4 theta, you use 4 theta and then 2 theta in the formula. Or if you see a 6 theta, you use a 3 theta. And notice how like 4 and 2, that's double of this one. 6 is double of 3. You could do 10 theta, and then what you would have on the inside would be 5 theta. 10 is double of 5. So here you can see where I have it written out. Maybe you saw it as a sine of 4 theta. You can break that up, and now if we look at our example up here, I'm going to make it so it's in view. So if you look at your example of your formula, it's saying that if you have 2u, then we're going to have u and u in our sine and cosine. So we really have 2 times 2 theta. So we have a 2 theta and a 2 theta. Down here we have 2 times 3 theta. So that's why you have a 3 theta and a 3 theta. So whatever you see here, if it's an even number, you can just divide it by 2, and then you have what belongs on the inside of your formula. So that brings us to our first example here, and there's a big dilemma. When you're looking at your example, they're asking us to simplify cosine of 3x just in terms of cosine, and the real problem is that 3x is not an even number. That's not really like a double angle. So this is where you need to be able to determine what other trig identities you can use. So let's start with cosine of 3x. So we know 3 is not double of any number, but maybe I can break 3 up. We learned a property last week that if you have 2 angles being added or subtracted on the inside, we have properties that help us break that up. So if we can break this up into something that is even, and then maybe something that's not. So we would really have cosine of 2x plus x. Okay, so whenever you have an odd function value on the inside, so like 3x, or if you saw 7x, break it up so that you do have one that's even, or one that is technically a double angle. So let's use a couple different properties here. So the first one that we're going to need to do is our sum and difference property. So we need to break up these 2 angles. So when we break that up, it's going to end up being cosine of 2x times the cosine of x, and then we have minus sine of 2x sine of x. So that's your property from last week, the sum or difference. So I'll kind of let you know what we're doing as we go through here. So to get from this line, we did our sum or difference property. Okay, so that's how we broke that up. Now we can take this step by step. So when I look at my first little piece of cosine over here, it's a double angle, which is what we were looking for. So when we break up our cosine of 2x, that becomes 2 cosine squared x minus 1, and that's still multiplied by cosine of x. And then when we break up, we see another double angle down here, the sine of 2x. So when I rewrite sine of 2x, that becomes 2 sine x cosine x. And that's still times sine of x. So here are properties that we used. Well, actually just one property in particular. We used our double angle properties, or double angle formulas. All right, so we can keep going. So what I'm going to do is just for my first big group of multiplication, I'm just going to simplify that. So we end up with 2 cosine cubed x minus cosine of x. Now, if you remember our directions for this problem, it asked us for our answer totally in cosine. Okay, so keep that in mind as you go forward. Now I'm going to distribute my sine of x, so I have 2 sine squared x cosine of x. So all I did between our two steps here was just distribute. All right, so now we need to keep working on this problem. So I still see a sine of x. I need to get rid of that. So my first couple terms are just going to stay, so I'm just going to rewrite them. So I have 2 cosine of cubed of x minus cosine of x minus 2, and we need to replace sine with something. So this is where you would reference your formula sheet. So we know that sine squared plus cosine squared equals 1. That's a Pythagorean identity. So we can rearrange that to get sine squared by itself. It's really going to be 1 minus cosine squared. And then cosine of x. So that's a big key here, is to be able to figure out how can I manipulate what we have. So we used a Pythagorean identity to change sine to cosine. All right, we're looking good. Now it's just a lot of simplifying and a lot of cleaning it up. So we have 2 cosine cubed of x minus cosine of x. I can distribute my 2 and my cosine at the same time, so I'm going to have minus 2 cosine of x and then plus 2 cosine cubed of x. So that's just another step where we distribute. And then our last step would just to be combine. So we end up with 4 cosine of cubed x minus 3 cosine of x. So notice how our answer does not contain any sines, and it has all cosine, and we were able to write it in a way that now we can work with. It's just 1x on the inside of this cosine function. So now we're on to page 2 of your guided notes. So on this page, you're going to see that now we have a way to rewrite when our function has an exponent, if it's squared. So the reason that we do this is that we can write powers of trig functions without the powers. We're able to use this without having to square or without having to have these higher degrees. So here's your 3 formulas. Make sure you copy them down. Again, these are already on your trig formula sheet. So again, that's something good to have in front of you. And then we also have our half angle formulas. This one's going to be a nice one to be working with. So you have your half angle formulas. So that's when, if you notice that the degree you have on the inside can be doubled and be a value on your unit circle, you can use this half angle formula. So the sign, like the positive or negative sign for these half angles, that's something that you have to determine yourself for cosine and sine. You need to be able to figure that out. And really what that depends on, whether or not it's going to be positive or negative, It just depends on where that angle of u over 2 lies. So there you go, the quadrant in which u over 2 lies. Oops. All right, there you go. So we are going to do this example together. So we are looking for the exact value of tangent of 15 degrees. So if you really know your unit circle, you know that this is not on your unit circle. But you can think about it. Is this half of an angle that is on my unit circle? And it is. Okay, so this is where you need to notice that 15 is half of 30. So that's going to kind of be your go-to. If you see that they're asking for an exact value and this value is not on your unit circle, see if you double it if you end up with a value on your unit circle, and we do. So I could rewrite 15 as 30 over 2. It's equivalent. I didn't do anything except for rewriting 15 as 30 over 2. Now I can see that when I'm working with this, my u value will be 30. So u equals 30. So, and keep in mind, 30 is in quadrant 1. So when we're applying our half angle formula, this becomes 1 minus the cosine of 30 over the sine of 30. You're using that u value because you can use your unit circle. So this becomes 1 minus root 3 over 2 over 1/2. You can make your numerator have a common denominator, and that's really like 2 over 2 minus root 3 over 2, so that's 2 minus root 3 over 2 over 1/2. And that 2 and the 1/2 actually get canceled, so your whole answer is just 2 minus root 3. Alright, so page 3. This is our last little bit of new information. We have 2 more examples till we're done. So on page 3, now we have 2 different sets of information. The first one is product to sum. So this is where if you notice that you have 2 trig functions being multiplied, we can separate them and we can work on them as a sum or a difference. Okay, and that depends on what we started with. So you have your 4 formulas here. Copy these down. Again, they're on your trig formula sheet. And you really need to pay attention to what group of functions you have on this side and the signs, like positives and negatives, in the formulas. They're going to make or break your answers here. So let's look at this example of 3. They're asking for what is the cosine of 3x times cosine of 2x as a sum or a difference. So I'm just going to rewrite my problem. So cosine of 3x, and it's multiplied by the cosine of 2x. Now what I like to do personally is I like to figure out what my u is and what my v is. So my u would be 3x, my v would be 2x. So when I'm applying my formula, it's not going to get too confusing because I can even write it with my u's and v's first and then fill in the values that I have. Alright, so for our cosine, the formula that we have here is the 1/2. I'm going to put a bracket there because that's times everything. And it's going to be the cosine of u minus v plus the cosine of u plus v. And then you close your brackets. So now that we've already decided what u and v are, we can fill them in. So you have 1/2 times the cosine of 3x minus 2x plus the cosine of 3x plus 2x. Close your brackets. So then we have 1/2 times the cosine of x plus the cosine of 5x. Now you can leave it like this. This is a good answer. You can also distribute your 1/2. So you have 1/2 cosine of x plus 1/2 cosine of 5x. And that's your solution. Alright, so now your sum to product. So kind of like going in reverse. You already have these broken up and you want to get them going together. And this is, again, be really, really specific on the order of your functions on the left-hand side and the order of on the insides and the positives and negatives. Very, very important that you take your time, write it out, and then solve your problem. So the example for this is on the next page. We're just going to go straight to that. And there's actually a typo on this page. You want to just make sure that you change this to as a product. It's already a sum. We can't make it a sum if it already is. So this should say make it a product. So we have the cosine of 4x plus the cosine of 2x. I'm just going to write my problem. So cosine of 4x plus the cosine of 2x. So this one, the formulas on this sheet use x and y. So I'm just going to use that as a reference. So my x is going to be the 4x and my y is going to be the 2x. Just so I know what is going where in my formulas. So we have our sum to product formula. And so we have, this would be 2 cosine. Oops, sorry about that. So 2 cosine of x plus y over 2 and that's going to be multiplied by the cosine of x minus y over 2. So that is now where you can plug in your x's and your y's. So we have 2 cosine of 4x plus 2x over 2 times the cosine of 4x minus 2x over 2. You can simplify these. So we have the 2 cosine of 6x over 2 times the cosine of 2x over 2. Simplify as much as you can. So we have the cosine, well, you can write the parentheses, you don't need to. So cosine of 3x times the cosine of x. And that is your solution because it is one product. It didn't necessarily say make sure it's cosines, but it is all cosines. And that's it. You wouldn't do anything else.